the rational zero theorem. This theorem comes as a result of us having difficulties in finding the solutions of a polynomial function with higher degrees. I mean, we can solve linear equation, we can solve quadratic equation, but anything higher than that becomes a little bit difficult. We need to find the possible zeros. So the theorem says, suppose you have f of x is equal to nx to the n plus a0, and this is a function, a polynomial function of degree n. And don't bother about the middle terms. Look at the last term in the n terms. This one is a constant number. And I'm going to put another constant number, which is the constant number of the leading term. So this is the leading number, leading coefficient. So the theorem is not that difficult. So what it tells you is, first find factors. But find all possible factors of a0, meaning what? Our constant term. Okay? Then the second thing that you would do would be find all possible factors of the leading term, an. Your zeros would come out, if there are any, would be the ratio of all the factors of a0 over a to the n. So you can have a bunch of possible numbers that you can use. I mean, this is not an exact science. This is a trial and error. So you really have to work hard which one is which. And once you get the skill, you know instinctively which numbers do you think would be the zero of the given polynomial equation. Let me give you one example. Suppose you have f of x is equal to negative x to the fourth plus 3x squared plus 4. Mind you, we can't use a quadratic formula to find the solution of this because x is raised to the fourth degree. So let's use the rational zero theorem. This is your a0. Your a0 is 4. Your leading term a to the n, an is negative 1. And the theorem states find all the possible factors of a0. So all possible factors of a0, which is 4, are what? Plus or minus 1, plus or minus 2, plus or minus 4. I mean, I have to list all of them. I can't leave any. And then I'm going to go ahead and do all the possible factors of my leading term. Of meaning what? Negative 1. This one is not that hard. The possible factors of negative 1 are plus or minus 1. Now the third one is build a ratio. Okay, so it has to be a0 over an. So it would be what? Plus or minus 1, which is possible factor, over plus or minus 1. Plus or minus 2 over plus or minus 1. Plus or minus 4 over plus or minus 1. This is how you are going to build. This one is all the possible factors of the leading term, and this one are all the possible factors of the constant term. In this case, because 1 is just 1, you're not going to end up with a fraction. So if you simplify this, you would end up plus or minus 1, plus or minus 2, plus or minus 4. Okay? So What we are assuming is if there are the zeros of this function, if there is a solution, then either 1 or 2 or could possibly be all of them could be the zeros of the polynomial. So but we have to do the test. So I can choose any number. Suppose, let's say if I have, let me do f of 1. If I put f of 1, negative 1 to the 4th plus 3, 1 squared plus 4. This I should get a 0. If it is not a 0, then 1 is not the possible solution. 1 to the 4th is 1. Minus 1 plus 3 plus 4. I'm sure you know negative 1 plus 3 plus 4 does not give us a 0. Right? So it's not 0 because it is 6. So I know 1 is not the possible 0. And you can keep on doing negative 1. Okay. Let me do 2. F of 2. Then I'm going to put negative 2 to the 4th plus 3 times 2 squared plus 4. 2 to the 4th is 16. 2 squared is 4, 12, and 4. And if you go ahead and simplify this, you end up with 0. So I know 2 is one of the solutions of the polynomial. And probably it could give me a hint. What about, since I'm raising it to the 4th degree and to the 2nd degree, which is an even power, maybe negative 2 could also work. Let me see. F of negative 2. So this is negative 2 to the 4th plus 3 times negative 2 squared plus 4. If you raise 2 to the 4th, 16, then you have what? Negative 16. Negative 2 squared is 4, 4 times 3 is 12, plus 4 is equal to 0. You know this. So 2 and negative 2 are the solutions. And then you keep on doing 4. What about 4 and negative 4? And I will leave that to you. There is another way of finding this just to prove. Maybe we should use our synthetic division just for an exercise. So let's write the dividend. But be careful, there is always what? There is a gap between x to the 4th and 3x to the 2nd, and a gap between 3x to the 2nd and 4. So I'm going to write negative 1 because there is no x to the 3rd. I'm going to put a 0. I have 3x to the 2nd, and there is no x to the 1st, so I'm going to put a 0 and 4. So I know my 2 and negative 2 in this instance are the solutions of the equation, so I want to prove that. Plug 2 here, and let's use the synthetic division. Drop down negative 1. Negative 1 times 2 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times 2 is negative 4. 3 plus negative 4 is negative 1. Negative 1 times 2 is negative 2. And then we have negative 2, and negative 2 times 2 is negative 4. And 4 plus negative 4 is 0. Okay? So we proved 2 is the 0 of the polynomial. You can also apply negative 2. It's not that difficult of a concept. Okay? Okay. Let's see. Okay, probably I will do one more, and to write them into factors. So f of x is equal to x cubed plus 7x squared minus 11x, plus 11x, minus 3. So we want to find the zeros of these. Okay. So possible factors. For A0, possible factors of -3 would be plus or minus 1 and plus or minus 3. And possible factors of 1 would be plus or minus 1. So the ratio would be plus or minus 1 and plus or minus 3. I'm not going to do all 4 of them. And mind you, it is difficult to find the zeros of x to the third plus 7x because I cannot use, I can do grouping, but you're going to get stuck. Good luck. You can try that. So I have to reduce this polynomial into a quadratic function, meaning what, x to the third degree. Okay? So this is the best way to find that. Now, let's do -3. Let's use -3 as our. So I'm gonna do this. I'm gonna use synthetic division. Everything is in descending order, so I'm gonna write 1, 7, 11, and -3. Let me just look at this. So I'm gonna do -3. So I'm going to drop 1 here. 1 times -3 is -3. 7 plus -3 is 4, right? And 4 times -3 is -12, right? And 11 plus -12 is -1. And -1 times -3 is +3. And -3 plus 3 is 0. I'm done, right? Now, look, how do I rewrite this? This as a factor of f of x. This and this as factors. This one is my 0 of -3. Therefore, my factor is x plus 3. If my 0 was +3, it could have been x minus 3. Because for what value of x is x plus 3 is 0 if x is -3. So if you write it in a factor form, it becomes x plus 3. Then you're going to go ahead and write what? X squared plus 4x minus 1. You see, this function x to the third plus 7x squared plus 11x minus 3 is a product of x plus 3 times and x squared plus 4x minus 1. This you're gonna use what? I'm not gonna do this for you. You can use the quadratic formula. In that case, because x is a second degree, then you end up with nice arena of solutions, Okay. I think we should end this, and then probably when you do further exercises,